Here is an explanation for the answer to final exam question number 59 in Electronics Demystified, 2nd edition. If you have the printed book, please see page 429. The question is asking us about the characteristics of a variable frequency oscillator, or VFO. It's designed to operate with one of the following 5 situations or requirements. Remember, given A, B, C, D, and E. Well, the correct answer, the short answer, is B. This thing is designed to operate into a high impedance load that constitutes a pure resistance. Here's where we connect the load in this particular circuit. It uses a junction field effect transistor. This is just an example of a generic variable frequency oscillator known as a Colpitts oscillator. We can tell that it's a Colpitts because of the tap between the two capacitors in the tank circuit or tuned circuit that determines the frequency. It is a variable frequency oscillator because we can vary this inductance, thereby varying the resonant frequency of that tuned circuit. This RFC, by the way, here, that stands for radio frequency choke. In any case, you'll find this and other variable frequency oscillator designs back in Chapter 8. This happens to be Figure 8-4B, also known as, again, a Colpitts variable frequency oscillator. Well, this output right here is connected in the source circuit rather than the drain circuit of this field effect transistor in order to minimize the impact of the load on the stability of the oscillator. It works best if we take the load from the source or the emitter circuit of a variable frequency oscillator like this rather than from the drain and the collector. But nevertheless, we still want this load to create as little disturbance as possible in the circuit, and the way to do that is to ensure that its impedance constitutes a resistance without any reactance. If we introduce inductive or capacitive reactance here at the output, that's going to have an impact on the entire circuit, including, unfortunately, the tuned circuit, because, as you can see, we have a more or less direct line right here. If we disturb the output with reactance, we're almost certainly going to create an effect that will disturb the frequency of the oscillation. So the best answer to this question is B, into a high impedance, purely resistive load.